Hey everyone, welcome to Module 3 of our course. In this module, we built a baseline LLM-based application. In the previous lesson, we learned how to call an LLM through an API. It sounds simple. We have a question, call an API, and get a response. But often, this isn't enough. Consider this example from our synthetic data set of questions and answers. We generated this in previous module. The question is, how can I share my report with my team members in a public project? The generated answer explains how to share a report by selecting the share button on the upper right corner of the report. It goes on describing the solution in detail. However, if we ask ChatGPT the same question, we get a very different but also specific answer. It tells us to use a 1DB account, log in, navigate to the project page, click on the Settings tab, and scroll down to Sharing. That sounds accurate, but it doesn't work in reality. The model hallucinates an answer. Using public APIs and LLMs as knowledge bases has its problems. They are trained up to a specific knowledge cutoff. Knowledge gained after the cutoff is not available in the model. For example, a support bot doesn't know about application changes made after the cutoff date. We also don't know exactly what LLMs were trained on. Training data might be inaccurate, contain outdated code, or be unreliable from the start. Hallucinations can also occur as models sample from probability distributions, producing non-deterministic outputs. These outputs seem very specific, but can be inaccurate. Updating, retraining, or fine-tuning LLMs is expensive, so we often use them as is. One solution is including relevant knowledge in the query prompt along with the question. But if we have the knowledge, why do we need the LLM? And this brings us to our next topic, which is the application architecture of our app.